In the previous example we did, we're calculating the number of moles of elements, we're calculating the number of moles of compounds. But I want you to understand that you could be asked to calculate the number of mole of a chemical entity in a compound. So here we have these two examples to illustrate that. Let's see. Calculate the number of moles of hydroxide ions in 5 grams of magnesium hydroxide. B. The number of moles of potassium ions in 3.5 grams of potassium chloride. So how do we do it? Let's see. In the first case, we want to calculate, and take note, we are calculating the number of moles of hydroxide ions. Take note. We want to calculate the number of moles of hydroxide ions in the compound magnesium hydroxide. So the first thing we need to do here first is that we have to calculate the number of moles of magnesium hydroxide, and we know how to do that already. So let's get started. A. So the molar mass of magnesium hydroxide. Now if you calculate the molar mass of magnesium hydroxide, you will have 58 gram per mole. That's it. So the number of moles, then we know number of moles is equal to given mass. The given mass in the question is 5 grams. It's equal to given mass 5 grams divided by the molar mass 58 gram per mole. So what do we have? We have 0.086 mole of magnesium hydroxide. Now I want you to take note that in 1 mole of magnesium hydroxide we have 2 moles of hydroxide ion. What do I mean? If magnesium hydroxide dissociates, this what we have. So we have magnesium hydroxide upon dissociation. It is going to give us magnesium, 1 mole of magnesium ion plus 2 moles of hydroxide ion. Take note of this. So 1 mole of magnesium hydroxide contains 2 moles of hydroxide ion. So we need to make use of this. Let's see. So we write 1 mole. Okay, good. 1 mole of magnesium hydroxide contains 2 moles of hydroxide ions. Now if that be the case, 0.086 grams magnesium hydroxide, it contains, we multiply these two, 0.086 multiplied by 2. What does that give us? It gives us 0.172 moles of hydroxide ions. So that's how we do it. You see that if you calculate and you end at this stage, you will have calculated just the number of moles of magnesium hydroxide. But the question wanted us to calculate the number of moles of hydroxide ions in magnesium hydroxide. So let's look at the second example. We want to calculate the number of moles of potassium ions in 3.5 grams of potassium chloride. Let's see. Potassium ions in 3.5 grams of potassium chloride. Okay. So we have B, the molar mass of potassium chloride let's use the second method to do this. The other method I showed you. Yeah, let's play with it. Okay, the molar mass of potassium chloride is equal to 74.5 gram per mole. So we can say that 1 mole of potassium chloride contains 74.5 grams of potassium chloride. So how many moles? X mole of KCl will contain the mass given in the question. Remember, the mass in the question is 3.5 gram. Contain 3.5 grams of KCl. So X is equal to 3.5 divided by, and here we have 0.047 mole of KCl. So this is the mole of KCl. But remember, we want to calculate the number of moles of potassium ions. So let's dissociate KCl. This is KCl. When it dissociates, it gives us potassium ion plus chloride ion. So 1 mole of KCl will give us 1 mole of K plus ion. So the mole ratio is 1:1. This means the number of mole ratio, the mole ratio of KCl to K plus is 1:1. So the number of mole of the potassium chloride is the same as the number of mole of the potassium ion. So moles of K plus ion is equal to 0.047 mole. Okay, so go ahead and try these exercises. That's it. Pause the video and try these exercises. Calculate the number of moles of A, calcium ions in 1.6 grams of calcium phosphate, aluminum ions in 3 grams of aluminum sulfate. So go ahead and try this. Okay, let's see what you've done. So the first question, we want to calculate the number of moles of calcium ions in 1.6 grams of calcium phosphate. So here we go. Let's start by looking at the molar mass of calcium phosphate. So if you calculate the molar mass of calcium phosphate, you will have 308 gram per mole. We were given the mass in the question, that is 1.6. Now we know that number of mole is equal to the given mass 1.6 divided by the molar mass 308. So what do we have here? We have 0.005 mole of calcium phosphate. Good. So this is the number of moles of calcium phosphate. Remember, we have to calculate the number of moles of calcium ions in calcium phosphate. So let's dissociate calcium phosphate and see what we get. Here we have calcium phosphate. So upon dissociation, we have plus so that's it. So we can see that 1 mole of calcium phosphate contains 3 moles of calcium ion. So the mole of calcium phosphate to calcium ion is 1:3. So we can therefore see that 1 mole of calcium phosphate contains 3 moles of calcium ions. So if that be the case, 0.005 mole of calcium phosphate will contain 0.005 multiplied by 3 divided by 1. And so what does that give us? We have 0.015 mole of calcium ion. Okay, so that's it. Okay, let's look at question B. We want to calculate the number of moles of aluminum ions in 3 grams of aluminum sulfate. So here I'm going to use the second method to do it, but you could still use the first if you want to. So B, we have the molar mass of aluminum sulfate. If you calculate it, it is 342. So 1 mole of aluminum sulfate contains 342 grams of aluminum sulfate. So if that be the case, X mole of aluminum sulfate contains 3 grams of aluminum sulfate. So X be equal to divided by, so what does that give? It gives us 0.009 mole of aluminum sulfate. And remember, we want to calculate the number of moles of aluminum ions. So let's dissociate aluminum. It gives us plus 3SO4 2 minus. So we can see the mole ratio of aluminum sulfate to aluminum ions. For every 1 mole of aluminum sulfate, we have 2 moles of aluminum ion. So we can therefore conveniently say that 1 mole of aluminum sulfate contains 2 moles of aluminium ion. So 0.009 moles of aluminium sulfate to contain 0.009 multiplied by 2, and that gives us 0.018 mole of aluminium ion. So did you get that right? So we've seen how we can calculate the number of moles of compounds, the number of moles of ions in compounds. Now let's see how we can calculate the number of particles. Earlier in this video we saw this, that 1 mole of every substance contains a certain number of particles, 6.02 times 10 exponent 23 particles. And we said that this number is known as the Avogadro number. Avogadro number, or the Avogadro constant. So that's it. Now, how can we calculate the number of particles in a substance? We can do that by making use of this formula. Number of particles are represented by N here is equal to number of moles multiplied by the Avogadro constant. Remember, the Avogadro constant is 6.02 times 10 raised to the power 23. So that's the formula we're going to use to calculate number of particles. Let's see how that works. Let's take a look at this example. Example 3. How many sodium ions? Take note here, we are not talking about number of moles of sodium ions. We are talking about sodium ions. How many sodium ions, let's underline the word, are present in an aqueous solution of sodium carbonate containing 2.65 grams of the salt. So how do we solve this? We need to follow the steps we followed in the previous examples. We need to first of all start by calculating the number of moles of sodium carbonate, and we deduce the number of moles of sodium ions. Once we have that, now we multiply it by the Avogadro constant. Let's see how it is done. So we want to look at it. So we move ahead. Moles of the molar mass of sodium carbonate. Let's begin from there. Is equal to 106. So the number of moles, we know that number of moles is equal to given mass. The given mass in the question is 2.65 grams. So we have 2.65 divided by 106. What does that give us? It gives us 0.025 mole of sodium carbonate. Okay, let's now calculate the number of moles of sodium ions. We dissociate this. We are going to have 2 moles of sodium ions plus 1 mole of carbonate. So we can see that from this equation, 1 mole of sodium carbonate contains 2 moles of sodium ions. So if that be the case, 0.0 0.025 will contain 0.025 multiplied by 2, and that gives us 0.05 moles of sodium ions. Now that we have the number of moles of sodium ions, we can now multiply it by the Avogadro number. So number of sodium ions is equal to 0.05 multiplied by 6.02 times 10 raised to the power 23. What does that give us? It gives us 3.01 times 10 raised to the power 22 sodium ions. So that is it. Let's look at the next. How many atoms are contained in 1.8 grams of sulfur? Note that the chemical symbol of sulfur is S, uppercase S. How many atoms are contained in 1.8 grams of sulfur? Let's see. Okay, if you look at sulfur on the periodic table, it has a mass of 32. So let's see. Remember, the mass of sulfur given in the question is 1.8. That's the mass of sulfur given in the question, 1.8 grams. So let's see what we can do. Number of moles of sulfur then. Number of moles of sulfur is equal to 1.8 grams divided by 32. 32 is the molar mass of sodium. That gives us 0.056 mole. So the number of sodium atoms, sulfur atoms, I beg your pardon, number of sulfur atoms is equal to 0.056 multiplied by the Avogadro number, 6.0223. What does that give us? 3.37. So that's what it gives us, 3.37 times 10 raised to the power 22 atoms of sulfur. So go ahead and try these exercises. Pause the video and try this. Okay, so let's look at it. The first question says, calculate the number of electrons contained in 2.8 grams of nitrogen gas. Now note that nitrogen gas exists as molecules, so you can see it there, N2, and in a molecule we have two atoms. I want you to take note. In a molecule of nitrogen we have two atoms of nitrogen. So let's get to the periodic table to see nitrogen. Here we have nitrogen on the periodic table. Nitrogen has a mass of 14 and an atomic number of 7. Since it has an atomic number of 7, it means an atom of nitrogen has 7 electrons. Remember, in the neutral atoms, the number of protons is equal to the number of electrons. So let's go back to the question. That's it. Okay, so let's look at the moles of nitrogen. gas, that is N2. So we have moles of N2. We were given the mass 2.8 grams of nitrogen gas. So we have 2.8 divided by 28. Where does the 28 comes from? One atom of nitrogen has a mass of 14. So 14 times 2, we have 2 atoms. 14 times 2 is what gives us 28. So here we have 0.1 mole of N2. 0.1 mole of N2. Okay. Now, but I want us to note that, let's write it down, one atom of nitrogen, one atom of N contains 7 electrons. Hence, one molecule of nitrogen, that is N2, that is a molecule of nitrogen, contains 14 electrons. Okay, bearing that in mind, therefore, we can calculate the number of particles. So, number of electrons is equal to the number of mole, 0.1, times Avogadro number, 6.02, times the number of electrons we have here, 14. So what does that give us? It gives us 8.43 times 10 raised to the power 23 electrons. So that's the answer. Did you get it right? Okay, let's look at the second case. Calculate the number of calcium ions in 1.6 grams of calcium phosphate. Okay, so we had done a similar example. Let's see. Now, in this case, we have to first of all calculate the number of moles of calcium ions. From the number of moles of calcium ions, we can now calculate the number of calcium ions. So we've been given the mass of calcium phosphate. That's it. So let's see. We have B. How do we do it? Okay. The molar mass of calcium phosphate we calculated it earlier on. It was 308. So the number of moles of calcium phosphate is equal to the mass of calcium phosphate, 1.6, divided by the molar mass of calcium phosphate, that is 308. This gives us 0.005 mole of calcium phosphate. Okay, now if we dissociate the equation, we have so that is it. The mole ratio we know of calcium phosphate to calcium ion is 1:3. So we have 1 mole of calcium phosphate so 0.005 contain this gives us 0.015 mole of. Now that we have the number of moles of calcium ion, we can multiply it by the Avogadro constant. So number of calcium ion is equal to number of moles of calcium ion multiplied by the Avogadro constant. So what does that give us? What does it give us? It gives us 9.03 times 10 raised to the power 21. Okay, so hope you found this video interesting, and you have no worries again with calculating or calculations involving moles and number of particles. So make sure you like the video, and if you've not yet subscribed to my YouTube channel, go ahead and subscribe and hit the notification button, so each time I upload a new video, you'll be the first to be notified. Thank you so much and have a nice time. Stay safe. Bye bye.